Hey guys, today we're starting Unit 2, Lesson 1. Unit 2, we're going to talk a lot about right triangles, the Pythagorean theorem a little bit and its converse, and then we're going to start to transition into some angle rules. So before we can do any of that, we really need to talk about square roots, simplifying exponents, and rational exponents as well, so that we know how to handle these. So the very first thing that I have for you here on your notes is all the rules about exponents that you should have learned in Math 1. Okay, and I just listed them out here. These are each of the rules along with the algebraic rule, okay, and then one example using numbers. So, like the product of powers, when you're multiplying two bases that are the same, you add the two exponents, okay? If you're multiplying a base or bringing a base to a higher power, then you multiply the exponents. For this, you would distribute that exponent to both the bases inside the parentheses. And we're going to write a note here in a little bit. I like to say to you that exponents are very, very snobby, meaning that they only talk to other exponents. Notice that the A didn't change and the B didn't change. The bases didn't change. Only the exponents did. Whenever we have a negative exponent, that's kind of like a little flag that says that you have to move it to the opposite side of the fraction bar. So in this case, this one happened to already be in the numerator, so we didn't quite see that denominator. But to fix it, we move it to the other side of the fraction bar, and then that negative disappears on us, but we still have our exponent value, whatever it is. Anything to the 0 power just equals 1. Quotient rule. If we're dividing two bases that are the same, we subtract the exponents. And then finally, this is no different than the multiplication up here with parentheses. You distribute that exponent into all the variables that are in the parentheses. You do the same thing here, okay? Wherever the variables are, that's where they stay, and then their exponents are altered. So that's our very quick review of our exponent laws. What we're about to do is go ahead and include rational exponents into this. Now, rational just means fractions, or also could be decimals, okay? So, rational exponents, we're going to use these same rules that you should have learned last year, but we're going to apply them when our exponents are fractions. Okay? So let us take a look at number 1. Number 1 is going to utilize the negative exponent rule as well as the product of powers rule. All right? So let me just get a different color. So looking at this, I immediately see a negative exponent. So to me, a negative exponent is like a little bright flag that says, move me, move me. So it's currently in the denominator, so we need to move it to the numerator. Okay, and so let me go ahead and write out to the side what this equals now. I have 2x to the 2/3, and now I have x to the 1/3. Now the 4 is its own base, so the 4 did not move anywhere. It's still in the denominator. All right, now we're ready to go ahead and use our product rule, which is if you're multiplying two bases that are the same, you're going to add these exponents. Fortunately, they already have a common denominator, so we can add them. 2/3 and 1/3 is 3/3 over the 4. All right, so we all know that 3/3 is just 1, so x to the first power here. And then I need for us to simplify the 2 over 4. 2 over 4 is the same as 1/2. So 2 and 1, so 1/2. 1/2 times x. And this is our answer. You could have also written this like this. X on top and the 2 on bottom. Both of those mean the same thing, 1/2 x. Let's take a look at example 2. All right, example 2 states, okay, here's where I have my little note. Let me scooch this over, and I'll even zoom in some. This is my note where I tell you that exponents are snobby little creatures, okay? They won't talk to bases. They only talk to other exponents. So they think they're above everybody else, and it's because they are. They're exponents, okay? So I see the power rule here, okay? Power of a product, or the product rule, power product, whatever. Now, what we need to make sure that we do is we need to know what all the exponents are for everything. So that's x to the first power. That's y to the 1/2 power. Now let's go ahead and we're going to distribute the 4. Okay, my 2 bases are not going to change. I have an x and I have a y. So when I distribute this 4, what I need to do for the x is do 1 times 4 and get 4. For the y, I'll do 1/2 times 4, which is 2. Okay. And then this 5 is just being multiplied by everything, but it was not affected by this 4, this exponent. So I just bring this 5 down. And you don't have to keep using the parentheses because all of these are just being multiplied together. And this is your final answer. Okay, let's take a look at what's going to happen when we see, when we see radicals, okay? Radicals. So here's what a radical looks like. N can be any number greater than 1, okay? N is going to be greater than 1. On the back side of my paper, I've got a little bit of room at the bottom. And so I used this space as a spot to kind of write our explanation of why the smallest n value is always going to be 2. Okay, it's got to be greater than 1. So here's an example where the root number is 1. So this is called a root. Okay. The root number tells you how many items you need in a group in order to be able to come out of root symbol. Okay, so this is the root number. This is the root. Okay, so if I only need a group of 1, here's how this would look. If I apply this rule right here, okay, so I take the base. In this case, my bases are 2 and 1. I'm sorry, 2 and x. And their exponents are 1 and 1. Okay, so if I take this root number and put it on the bottom, so that's a 1, so put a 1 under there. Okay, that's where that 1 came from. And so then you simplify these. Well, 1 over 1 is just 2 to the first power. 1 over 1 is just x to the first power. And so really it's the same answer if you just have the first root of something. So the smallest root that we use is 2, okay? So if you just see a symbol with no number here, you're expected to know that it is a 2, all right? Okay, so let's talk about this rule. Now, this rule and this rule are exactly the same, okay? I just flipped it around backwards so that you could see what it would be like going from a root to a fraction, or what it would be like going from a fraction to a root, all right? Alrighty, so let's do this example number 3 together. So this is a 4th root, and I have a 2 to the first power, and I have an x to the 3rd power. So this root is going to become, that root number becomes the bottom of your fraction, okay? You're going to create the fraction using that number. So over 4 and over 4. So what this really is saying is that I have 3 x's, but to come out, I needed 4 x's. So I had 3 out of the 4 that I needed, and I can just write that as a fraction, okay? For the 2's, I only had 1 2. I needed 4 to be able to take it out of the root, so I didn't have enough, so I only had 1 out of the 4 that I needed. Let's look at this same rule going the other way. Now, what I like to tell people is that when you're going the other way, think of it like this. The bottom of the fraction is going to drop out and become the root number. So back in the day, there was this song I used to listen to called I've Seen Better Days. And there's a phrase in that song that says, and the bottom drops out. Okay, so I use that to help me remember what to do with the bottom of the fraction. Okay, so you've gotten to hear part of the song anyhow. Let's go ahead and do our example number 4. So I have 3 to the 1/2 power and x to the 3/2 power. So I'm going to take the bottom of the fractions. Now they are the same number, okay? So that means I can put both the base 3 and the base x in the same root. So the bottom drops out and becomes the root number. And now 3 to the first power is what I'm left with here, and x to the 3rd power is what I'm left with in there. And that's it. That's how we go back and forth using our rule. All right. Let's go ahead to the back side of our paper and take a look at a few examples. All right, so for this example A, it's going to be really important that you remember how to simplify a square root. And this does say square root. My pen started to die on me. Okay, so we're going to look at that in example A just to kind of help you remember. The reason I can simplify example A all the way down till I have a single answer is because it's all numbers, okay? So here's what I'm going to do. I am going to, first, I am going to change Actually, I'm going to leave this just how it is, okay? Let's go ahead and simplify what's inside this square root, or fourth root, forgive me, fourth root. So inside this fourth root, you need groups of 4, okay? So I'm going to break this 32 down 3 times because there's 3 of them. That's what that cube means. So 32 times 32 times 32. Okay. Next, what I need to do is break these down further. So this would be the same as 8 times 4. And actually, they all would. 8 times 4. Okay. And then I can break the 8s down into 4 times 2, 4 times 2, 4 times 2. Oh, I wrote that in the wrong spot. Whoops. But I really did break down the 8. Okay. And so what I'm noticing is I do need groups of 4. So let's see if I have any groups of 4 yet. I see 1, 2, 3, and 4. I see 4 4s. So I'm going to go ahead and take out a 4. Okay. Next, I see 1, 2, 3 2s and 2 4s. All right, so let's go ahead and break down these 4s even further. So this is 2 times 2 and 2 times 2. This is just a factor tree, guys. Let me get a purple pen. And I'm going to try to circle 4 2s, okay? 4 2s. So 1, 2, 3, 4. So I got 4 2s. So I got 1 group of 2s came out. Okay, now we got to think about what is stuck inside there. What can I not take out? So I still got this fourth root. And now what do I have? Well, I see 2, 2, and 2. So I have 2s. And how many do I have? I have 3 of them. Okay. So that is almost simplified. The last thing that you would need to do is put this 8 and 2 together. Okay. 8 and 2 together to get, 4 and 2 together to get 8. So let me just write this now. This gave me 8. I want to write this as a fraction. So let's do the root comes down. So I have 2 to the 3/4 power. So 8 times 2 to the 3/4 power. And that is all being squared. All right. Now let's go ahead and do 8. I would distribute this, by the way. Let me use pink. So this is to the 1st power, and this is to the 3/4 power. So you distribute this 2. So now what I have is 8 to the 2nd power, which will simplify and give me 64. Okay. Then I have 2 to the, this is 3 times 2, which is 6 over 4. 6 over 4. Alrighty. And then I am going to see if I can simplify this anymore. So I have 6 2's now. So if you broke this up, you could pull out a 2, and then you're left with a 2 to the 1/4, to the 2/4 power. Okay, because 6/4 is the same as 4/4 plus 2/4. 4/4 is a group of 4 that you needed, so that's just the 1. Okay, now let's do our 64 times 2 and simplify that 2/4 to 1/2. Okay, and then we're ready for our final answer. So this would be 64 times 2 is 128. And then I've got 4 to the 1/2 power. So what that's the same as is, oh, I'm so sorry. That's a 2 to the 1/2 power. So the bottom is going to drop out and become the root, and inside I'm left with 2 to the 1st power. So 128 square roots of 2. That is, gosh, that's my answer for part A. And look at all this scratch work. I'm going to box this in, okay? So when I'm dealing with numbers, there's really a lot going on there in order to simplify it all the way. Now, I simplified this completely down 100% as far as I could go. That is about as involved as it gets. It uses our exponent rules that you learned. It also requires that you remember how to simplify roots, but not even that. It also utilized our rule for us to go from a root to a rational exponent. It really used everything. I think in the example B, you're going to find that when I have variables, it actually is a lot easier, okay? Variables are much easier than numbers. So let's take a look at example B. So here's what I'm going to do. I am going to, because this is a rational number, it's an exponent, I need to make this be an exponent, okay? So my root is going to become the bottom. The root is going to become the bottom of the fraction. So b to the 3/5. And then I have b to the 4/3. So here's my question for you. Think about which of these two fractions is bigger. Which fraction is bigger? Well, 3/5 is part of a whole. 4/3 is one whole amount plus a little more. So the 4/3 is the larger fraction. Here's what I do personally to try to avoid negative exponents, okay? Because that way it just kind of saves you an extra step also. So whatever the bigger exponent is, in this case it's on the bottom, so I am going to do the division rule of exponents says that you subtract them. So the bases are the same, the bases are being divided, so I subtract the exponent. Well, I always suggest that you subtract the bigger, right? So wherever the big number is, you use that number and subtract the smaller number. And here's how it's going to look. The final answer, because the bigger exponent's on bottom, you know that the final answer is going to go on bottom. And now let's do our exponents. So I need to do 4/3 minus 3/5. This requires that I use some fraction knowledge. So in order to subtract fractions, you need to have a common denominator. So let's say that the common denominator, the LCD in this case, is going to be 15. So 5 times 3 is 15. So 3 times 3 is 9. And then let's do, how do I get from 3 to 15? I got to multiply by 5. So on top, I'm going to do 5 times 4 and get 20. Okay, now I'm ready to actually subtract. So 20 minus 9 is 11, and I keep the denominator the same. So my b here is to the 11/15th power. Okay, now what do I put on the top of the fraction? I got to have something there. So I'm just going to put 1 as a placeholder. Okay, because I did this minus that, and it ended up on bottom so that it could remain positive. And then let's box in this final answer. Alrighty. Let's look at an EOC or NC final exam example. So I want you to write this as an expression with rational exponents. Okay, so we can do that. The first thing that we're going to do is separate out the 27, okay? Numbers you can handle. Variables end up being a lot easier than numbers, I promise. So I've got the cubed root of 27. So I'm going to simplify this. Well, 27 is the same as 9 times 3. And then you can break that 9 down some more. 3 times 3. So I have 1, 2, 3 3s. Well, 3 is the exact number that I needed. Okay? So that equals just 3. So I've simplified my numbers. Okay? That's 3. Now I'm going to bring down the x, y, and z. X, y, z. Remember, I crossed my z's. And then I'm going to bring down their exponents. So 2, 6, and 3. 2, 6, 3. And now let's take this root number, and it's going to become the denominator for all 3 of these. And I am ready to simplify and get my final answer, which is 3x to the 2/3 y to the 6/3. Well, 6 divided by 3 is 2. And then I have a z to the 3/3, which is z to the 1st power. You don't have to put that 1 there. And there's my final answer. Okay? Alrighty. Here's something to think about. Given 81 to the 3/4 power equals this right here, which can also be written this way, by the way. You can write this with the exponent underneath the root, or you can handle this first and then do the exponent after, okay? Which form would be the easiest to calculate without using a calculator? And we're going to justify our answer. Okay, I don't know about you, but I do not know how to make sense of this in my brain. 81 to the 3/4 power. I'm a little lost, okay? I personally think that it is much easier to handle this without a calculator. And we're going to do that really quick because it's very, very simple, right? So I need 4 groups of the same thing. So let's do 81, and I'm going to factor tree it, which is 9 times 9. And then each 9 breaks down to 3 times 3. So I have 3 to the 4th power. Okay, well, this becomes 3 to the 4th. And then I take out the root number and pop it below, which is just 3. Okay, now I saved this cubing for last. So we need to remember to cube it now. Okay, so 3 times 3 is 9. 9 times 3 is 27. I was able to do that really quick without a calculator, okay, because it's basic multiplication and then using that rule. And now if you want to check it with a calculator, you can. Let's do that really quick. Okay, so for any of my Android users out there, there is an app for your Android phone. Let me just zoom in here. It looks like this, in case you choose to go to the App Store and go grab it. Wabbit, Wabbit. It looks like a rabbit next to a graphing calculator. It's free for Android users. I believe Apple charges a fee for this app, but I don't know how much. Whoops. So that's what our app looks like. If you click it, I now have a regular looking TI-84 graphing calculator built right into my phone. That'll save you about $120 if you were to go to the store and buy a graphing calculator. Okay, so here's what I'm going to do now. I'm going to type in 81 to the 3/4 power and check our answer, see if we did it right? So 81, you can raise it to any power using what I call the caret button. So caret, and then I'm going to type up there 3 divided by 4 and hit enter. And the answer they got is 27, which is the same answer that we got. Okay, so you can do this by hand without a calculator pretty easily, but the form does matter. Okay, it does matter. All right, we are on our very last example. Determine whether each equation is true or false using the properties of exponents. If false, describe at least one way to make the math statement true. Okay, so to figure out if these are true or false. So let's go ahead and take a look at this. Okay, so 2 to the 5/2 power, what I am going to do is turn this into a square root. So let's go ahead and do that. Draw an arrow for part A and try to make this less blurry. There we go. So the bottom drops out. So I'm going to have a square root of 2 to the 5th power. Okay, now let's think about what is 2 to the 5th power equal to. Okay, so 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. So number 1 is true. That's a true statement. Let's think about B, okay? So 16 to the 3 halves, does that equal 8 squared? All right, so I'm going to draw a line to the other side of this paper. There it goes. So 16 to the 3 halves. Okay, so I'm going to say the bottom drops out and becomes my root number. And then I have 16 cubed. 16 cubed. 16. Here's the easiest way for me to do it. Okay, I'm going to do 16 times 16 times 16. Alrighty, I need groups of 2. Groups of 2. So let's do, well, hold up. I see a group of 2 already. Look at this. There's a group of 2. I got 2 16s. So take that out. And now I'm going to break down this other 16. Let's see. 4 times 4 is 16. And now I see a second group of 2, which is 4. Okay. When you take those out, remember, you still have to keep multiplying them together because under here they were all being multiplied. So when you take them out, they should also be multiplied. And so 16 times 4, well, that is 64. And now they have 8 squared. What does 8 squared equal? So I don't know if you've ever heard this before, but the way I learned my 8 times 8 was phonetics when I was a long time ago when I was in school. So they taught us little rhymes. So I ate and I ate till I got sick on the floor. So 8 times 8 is 64. I don't know why. That's really the only one I remember. So, but yes, these both ended up equaling each other. So B is also true. Okay, let's look at C. Let's see if we can figure out if C is true or false. So I'm going to put this one right here. All right, so the bottom's going to drop out, and I'm going to have the square root of 4 to the first power, which is the same as 2. The square root of 4 is 2. Okay, now let's try to do the square root of, this is the fourth root of 64. So the fourth root of 64. So I could do 8 times 8, right? And then I could break those down into 2 times 4 and 2 times 4. But I still don't have any groups of 4. So let's break the 4s down even more to 2 times 2. And let's start the circle. I'm seeing a lot of prime numbers now. I have 1, 2, 3, 4 2s. So this will come out and give me a 2. But I've got these leftovers in here. I've got 2 squared. Okay, there's 2 of them. So two squared, the fourth root of 2 squared. Are these the same? The answer to this is no, they are not the same. Okay, it did want us to describe at least one way to make the statements true. So maybe if instead of 64, if this number in here was 16, then it would have worked out okay. So this number was actually too big. Okay. All right. Let's look at D. So 2 to the 8th power. I think we did that earlier, but let's just go ahead and run through it again. 2 times 2 is 4, 8, 16, 32, 64, 128, 256. I got 256 out of my 8 twos. So I'm going to put D over here. Okay, so 2 to the 8th power, I got 256. Now let's do the 16 down here, to the 6th power. So the cube root of 16, so 16 breaks down to be 2 times 2 is 4, times 2 is 8, times 2 is 16. Okay, so I have 4 twos. All right, let's convert this. So the 4 over 3, 2 to the 4 thirds. And then I need to raise this to the 6th power. So let's do 2. 4 times 6 is 24. And then there's the 3 on bottom. What's 24 divided by 3 equal? 2 to the 8th power, which is the same as this. So D is true. D is true. Now let's look at part E, and then we're done for today. So I have 64 to the square root of 64 to the 1/3 power. Okay, so this is E I'm breaking down. So the square root of 64 is the same as 8. To the 1/3 power. Okay, so that's the same thing as 8 to the 1/3 power. Well, 8 to the 1/3 power cannot possibly be the same as 8 to the 1/6 power. So one way that we could have fixed this is by maybe putting a 2 in front. No, this should have been maybe, what would we have to do? We'd have to multiply it by a half. So if this was 1 over 6 instead, then it would have been the same. Okay, but that's false. Okay, well, that is the end of our lesson for today. Be sure to check out your practice assignment. Until next time, bye guys.